then 50% means what? Question asks highest income of lowest 50% of work. Lowest 50%. Okay, the lowest 50% worker, this is the what? Highest income. Which measurement represents? Q2 or what is it? Median. Now clear? Okay, then this Q2 or median here represent what? This is the highest income of the lowest 50% of the. It's clear? Okay, then what the median value is here? Five point 125. Okay. Last day we calculated for the median value is 25.125. And this is the highest income earned by the lower 50% of the workers. Understood? This is the lowest 50% of workers, and median represent the highest income level. Okay? Then other way, how is it? We consider about the top 50% of employees. This represents what? They are lower income. Okay? Then this is the 25.125 is the lowest income earned by the top 50% of the employees. Why this is the top 50% of employees? This is their lowest income. Okay, then they earn 25.125 or greater than this value. These are the top 50% of the employees. Now clear? Okay. Then tell me next one. What is the measurement we can calculate? Which measurement? Yes, minimum income earned by the top 25% of the work. Top 25%. Okay. And this says minimum income earned by the top 25% of the work. Which measurement? Q3, third quartile. We consider the third quartile greater than the third quartile, 25% of the data. Okay, then Q1, Q2, Q3. Represented 25%. Means top 25% of workers, this income is their minimum income. Understood? Why? This is the top now. It means they earn Q3 or greater than the Q3. Okay, then the Q3 means their lowest income, minimum income. It's clear. Then here you need to find out the Q3. Then this is the group data distribution. How do you find the Q3? Yes, and tell me how do you find it? And here you need to find out the Q3. Okay, how we find the Q3 in here? We studied how to calculate the Q3 in the row data set. But here, group data distribution is there. How we find? Yes. Here, you can use the median formula. Okay. Some adjustments we need to make. Okay. Then here, first one is L1 is there. Median formula. Addition. The next one is n divided by 2. But here, we need to write down n divided by 4. But this is the third quartile. Therefore, we need to multiply by 3. Median formula, we get n divided by 2. By using the median, we can divide into equal to parts. Okay, then how many cut points we need to divide into 2 equal parts? Only 1. Therefore, we take n divided by 2 only. But here, this is the Q3, third cut point. N, we need to take n means how many observations are there. These observations we divide into 4 equal parts. Q3 represents the third cut point. Now here, then others are same. Minus FC divided by, here we write FQ. Okay. FM means median frequency of the median class. Here we write frequency of the third quartile class into 3. Now clear? Okay. The data set. Okay. Here we need to find out what? First, we need to find out the 3F column. Okay. Already you did, okay? This says when here 5, 15, 30, 50, 60, and 65. It means total number of workers equal to 65. Then you can simplify it. Starting from here. 3 into 65 divided by 4. What is the answer here first? Three into 65 divided by 4. What is the answer? .75. Then simplify it, then we got the 48.75. Then 48.75. Now we can find out the relevant class interval. Okay, then we move it down to the CF column. Okay, then tell me where is the 48.75? Fall into which class interval? Okay, then this is the third quartile class interval. Okay, it's the class interval, it represents the third quartile. Okay, then what is the L1? What is the L1? Tell me. L1 means lower class boundary. Then here here 25 is the lower limit. Then what is the lower class boundary? 24.5. Okay. Then here cumulative frequency. Here we write previous class interval cumulative frequency. Okay. This is the previous class interval. This is the cumulative frequency. What is the answer here? 30. Okay. Then here we need to write down the frequency. Frequency means here. Okay, what is the frequency value in this class interval? 20. What is the meaning of the C? Size of the class interval. What is the size? 5. Then you can simplify it. Find out the third part I did here. Yeah. $29.1875. And 29.1875 is the minimum income earned by the top 25% of the world. This is the interpretation of this value. It's clear how we interpret this answer? 29.1875 is the minimum income earned by the top 25% of the world. Clear? Then try last one. Then which measurement here we need to calculate? Maximum income earned by the lowest 25% of the workers. Which measurement? Q1, first quartile. Okay, then below to the first quartile, it represents the 25% of the data. Okay, then Q1 represents their maximum income. Okay, then Q1 represents maximum income earned by the lowest 25% workers. Then here, try to find the Q1. Q1, how we find L1 plus L divided by L5 divided by 2. This class is 20 to 24. Sixteen point something, 65 divided by 4, it means this class interval, by here 30, then up to that point 15, here 30, and then here what's it over limit? 19.5. What's the previous EF value? 15. Here frequency value 15 into 5.
Oh.
19.9. 19.92 is the maximum income earned by the lower 25%. Now clear what I am? Okay. Important thing is interpretation. Okay. We can get the output using the Excel or any software. The interpretation is not there. Okay, then all the time you try to study how we interpret the answers. Okay. Okay. Then we move into the new lesson, the third measurement. All of you bring your calculator. Now we study central frequency measurements and the measures of location. Okay. Third one is measures of dispersion. In the measures of dispersion, we use to find out the variation or variability of the data set. Okay, then the measures of dispersion represent what? It gives information about the variability of the data set. Clear? Okay. Then using the measures of dispersion, we can identify the variability of the data set. Okay. Then here, we assume this is our data set. Okay, this circle represents the data set. These are the observation values. To find out the variability, how data is distributed in this data set. The mean of the variability. Okay, then here we find out the spread. Okay, then before find the variability, first thing we need to identify what is the center point in our data set. Center point. Let's tell me how we find the center point using what? Central tendency measurements. Using the central tendency measurement, we can identify the central point. Okay, then we assume this is the central point in this data set. We find out the X bar value in this data set. It's the central point. Okay? Then the measures of dispersion is what? What is it? The degree to which numerical data tend to spread about and the average value. Okay, then how we find the variation? About and the average value. This X bar represents the average value, then we find out the spread. How these data spread about and the average value. It's clear. This one we call as measures of dispersion. Using the measures of dispersion, we can identify the variation or variability of the data set. How we find out? Here we identify the variability or variation from the average value. Okay, spread, විතිරීම. මෙතනදී අපි ඒක බලන්නේ අපේ data set එකේ average point එකේ ඉඳලා කොහොමද spread කරලා තියෙන්නේ. Understood? That is we called as measures of dispersion. Here we identify the how data is distributed from the average value. Here how data is spread about at the average value from the average point. Okay, අපි කොහොමද මොකක් හරි දෙයක් ඉස්සරලා තියෙනවද කියලා බලන්නේ මේක point එකක ඉඳලා. එහෙම නැත්නම් බෑන් data set එක දිහා බලන්න. Okay, then the point is central point. Here we find out the mean value as the central tendency measurement. Then we take how these remaining observation values spread about at the average value. Is measured by the measures of dispersion. Now clear? Okay, then this is the objective of the measures of dispersion. Here says the degree to which numerical data tend to spread about an average value is called the variation or dispersion of the data set. Dispersion means variation, variability. Now clear? Okay. Then here different types of measurements are there. We can find out the variation of the data set. Okay. The first measurement is range. Okay, then range is the simplest measurement. Okay, then here range we can easily calculate. Okay, then here we require only two informations to calculate the range value. Then how we calculate the range? How we calculate the range? We calculate maximum value minus minimum value. Okay, then range is the simplest measurement, right? Only we require two information. Observing the data set, we identify what is the highest value, what is the lowest value. Then we take the difference between these two values. It's clear? Okay. Based on the range value, we can identify the variation of the given data set. Understood? Okay. Then here, range, the advantage or merit of the range, easily we can calculate. Okay. Then quickly we can calculate. Okay. Then what? There are some disadvantages. What are? Here we consider only the maximum and the minimum points. We do not consider about the other remaining observation values. Using two values, we calculate the measures of this dispersion, variation of the data set. This is the disadvantage of this measurement. We easily calculate කරන්න පුළුවන්. quickly අපිට calculate කරන්න පුළුවන් information දෙකයි ඕනේ. හැබැයි disadvantage එකක් තියෙනවා මේකදී අපි දෙන්නේ කියලා විතරයි කරන්නේ. Other observations we do not consider. It's clear? Okay. Then another thing is how we interpret the range value. Okay. Then here we take there are two classes, class A and the class B. We conduct the same examination to the both class. Then we identify the highest value and the minimum mark of each class. We assume class A 75 is the maximum mark, minimum mark is 50. But class B, highest mark is 90, but lowest mark is 20. Okay. Then here we need to find out which class has the more variation. We can do it. Okay. Then how we find out? Then we have only the maximum and the minimum mark. Then we can calculate what? Range value. Okay. And what is the range value? Here 25. Here 7. And then variation high in which class? Class B. Understood? Okay. Then class A variation is less. It means consistency is high. Consistency means they're looking at the class A. Highest mark is 75, but the lowest mark is 50. Okay, then all the students are in the average level. Okay, then we take the performance level, then put in the class A, not the class B. Their highest mark is 90, but the lowest mark is 20. Understood? Then the consistency is high in the class A. Variation high in the class B. It's clear? Okay. Then we take the overall performance. Which class is best? Class A. Understood? Okay. Then this is the way we can interpret the range value. But accuracy is less. Why? Here we consider about only the maximum and the minimum mark. Then we assume. Then here highest mark is 90, lowest mark is 20. Okay. Then we do not consider about the other remaining marks. And here sometimes only one student got 20 marks. Rest of the all other students got more than 75. Maybe. Okay. Then what happened to our decision? It's wrong. Understood? Okay. We need to get the rough idea. Then we can use the range. But accuracy is less. Why here we consider about only the maximum and the minimum mark. Understood? Okay. Now here, then this is the first measurement. This one is easily we can calculate, and this is the simplest measure of the dispersion. Understood? The next one. Then here we calculate the range value using the observation value. Other way we can calculate the range value using the quartile. Okay, using the quartiles we can calculate the range value. Okay, then tell me, normally range is what? Maximum minus minimum value. Then using the quartiles, which one is the maximum point? Q3. What is the minimum point? Q1. Then Q3 minus Q1 is the interquartile range. Okay. Then semi means normally half. Then we take the interquartile range then divided by 2. What is it? Semi interquartile range. Understood? Okay. Nothing new in here. Using the quartiles we can find the range. Normally range means difference between maximum and the minimum. Out of the quartiles, maximum point is Q3, minimum point is Q2. Take the difference between Q3 and Q1, represent the interquartile range. But here we consider the semi-interquartile range then divided by. Okay, then interpretation is same as in the range value. Semi-interquartile range is high, it means variation is high. Semi-interquartile range is less, it means variability is less, but consistency is high. Okay, then variability and the consistency, there is a negative relationship. Variability high means consistency less. Understood? If you value consistency now clear? Now we move into the next tool. Next measurement is the third measurement, variance. Range and the semi-interquartile range, both measurements are used only two values, maximum and the minimum point. Okay? Then here, when we move into the variance, here we use all the observation values to identify the variation of the data set. It's clear. Here we consider all the values. Okay? Then we take the example and we discuss it. Then we assume there is a data set. Okay, then we take the example. This is our data set. Here we need to find out the variation or variability of this data set. Okay, now we have for your observation. Okay, then normally variance or dispersion means what? We identify the spread about and the average value. Here we identify how these observation values are spread about and the average value. Here, අපි dispersion එකේදී බලන්නේ අපිට දීලා තියෙන data set එකේ ඒ හැම observation value එකක්ම average එකේ ඉඳලා කොහොමද spread වෙන්නේ. It's clear? Okay. Then here we need to find out how these 5 observation values are spread about and the average value. Then first we need to find out in here what is the average point. Okay. Then here sum is 25 divided by 5. What is the average value? 5. Okay. Then this is our average value according to this data set. Now we find out the variation of this data set. Okay. Then variation spread means what? Take the difference between mean values and the observation values. Understood? This is your mean value number 5. 5 is the mean value, average point. These are the given observation points. Now we find out the deviation. It means difference. Then tell me first difference is 4 minus 5 minus 1. Then 5 minus 5, 6. 6 minus 5 plus 1. 8 minus 5 plus 3. 2 minus 5 minus 3. The way we can get the deviation, then we identify the deviation of each observation values from the average value. It means observation value minus average value. Okay. Then this is the deviation, this is the dispersion. We add them all the values together. What is the answer here? The answer. Then what happens? We cannot make any decision. My answer is C. Okay, then when you use any data set, take the deviation, observation value and the average value. Finally, we take the sum. What is the answer? C. You use another 5 or 10 observation value, then take the sum. What happens? You will get the C. Understood? Okay, then based on that, we cannot make any decision. But here, when we calculate the variance, we take square value of this deviation. Square value, you know, square, Vargasaran. Okay, these are the deviation. This is the sum of the deviation. But all the time, we can get the sum of the deviation is equal to the 0. Okay, then we take the square value of this deviation. What is the square value? Minus 1 plus 1. Then here 0, then here plus 1, then 3. What is the square value? 9 minus 3 square value plus 9. Then what is the answer? 20. Now we have the value 20. Okay, then this is we call that sum of the square deviations. This is the sum of the deviation. Okay, then all the time sum of the deviation should be 0. Therefore, we get sum of the square deviation. Understood? Okay, then 20 is the sum of the square deviation. Then this sum of the square deviation we divide by number of observation minus 1. Why? Reason is two various values are there, population variance and the sample variance. Which one we can calculate? Population or sample? Sample. Statistic. Only we can calculate the statistic. Then we get the square deviation value, then n minus 1. Then what's the answer here? What is the variance? Understood? Okay, no need to study how to do it manually. Okay, then we can use the calculator and directly we can get the variance. Okay, then here, now here, how to get the variance value? But here, when we calculate the variance value, we do overestimation. Why? The variance value does not represent the reality. What is the reason? We consider about what? Standard deviation, not the deviation value. We take the deviation value, we square it. Then there is the overestimation. Understood? Then this is the disadvantage of the variance. Okay, then variance represents the variability or variation of the data set. But here we do not consider about the deviation. We take the square deviation. Deviation එක නෙමෙයි ගත්තේ ඒව square කරලා ගත්තේ. එතකොට overestimation is there. Understood? Okay, then there is a limitation. Therefore, we move into another measurement that we call as standard deviation. Understood? Why there is a limitation? Here, overestimation is there. How to minimize it? We can find out what? Standard deviation. It's here. Standard deviation is positive square root of the variance. Why take the square root? Then here we consider about the square deviation. Square values are there. How we can minimize it? Take the square root, but we should take which square root? Positive square root. Then here is 5. Okay, then here standard deviation is positive square root of here, then we assume our variance is 4. Easily we can get the square root of what is the square root value? Variance is 4. Then standard deviation is square root of 4. Then normally square root of 4, but again mathematically only 2. Plus 2 or minus 2 both. Not the 2. Square root of 4 mathematically plus 2 or minus 2. Right? Plus 2 square plus 4. Minus 2 square plus 4. Understood? Plus 4. We can get the two answers. Plus 2 or minus 2. But here standard deviation is only the positive value. Why we select only the positive value? The reason is dispersion value cannot be get the negative value. That is the reason. The dispersion value, okay, cannot be get the negative value. Can be 0, but cannot be get the negative value. First we studied range value. Okay, then tell me, can we get the negative value for the range? Cannot. Why? Range is maximum value minus minimum value. Difference between highest and the lowest, all the time we can get the positive value. Now then what else? Q3 minus Q1 divided by 2. Then can we get the negative value? We can't. Why? Q3 is greater than the Q1. Okay? Then variance. Can we get the negative value? Can we get the negative value? Can't. Why? What is the reason? Here we take the standard deviation. We take the deviation value square it. There is no any negative value. Okay? Then standard deviation cannot be get the negative value. Therefore, we get positive square root of the variance. Understood? Dispersion. Using the measures of dispersion, we identify only the variation. Spread. It cannot be get the negative value. Okay, then variation can be 0. No any variation. Where the dispersion is equal to 0. Spread එකක් නැති වෙන variation එකක් නැති වෙන්න පුළුවන් කොහෙද? Then assume there are 10 observation values. Then the deviation is equal to 0. Yeah. All the 10 observations are in the same value. So the there is a dispersion. The variation is of the 0. Understood? Measures of dispersion can be get the 0 but cannot be get the negative value. Therefore, in here we take the positive square root of the variance. Understood? We studied 4 measures of dispersion. Out of these 4, which one is the best? Standard deviation. Okay, then in the statistical analysis for the calculation part, we use the standard deviation only. All other 3 we do not. Okay, then statistician, first they identify range. When there is a disadvantage, then they move into the partial. Then they find out the variance. There is a mistake, and they find the standard deviation. Then out of these measurements, standard deviation is the best measurement. Okay, then the statistical analysis, inferential statistical techniques, we use the standard deviation, not the variance, not the range. Understood? It's clear? Then take the calculator. Using the calculator, only you can calculate the standard deviation. Okay? Okay, then using the calculator, only you can calculate the standard deviation. If you need to get the variance, How we convert calculator gives only the standard deviation. Then assume you need to get the variance. How we get it? I calculated the standard deviation. Then called variance according. How we convert into the standard deviation to the variance? Standard deviation is positive square root of variance. Okay? If we know the standard deviation, how we get the variance? Then assume 4 is the variance. Okay? Then variance is 4. Then standard deviation is 2. Take the square. We know the standard deviation is 3. How we get the variance? Square. What is this? Okay. Then using the calculator. Okay. Then you know how to calculate the mean value using the calculator. Remember now. Okay. Then first step is same. Okay. Then first you enter these 5 numbers to the calculator. Same method. Press the mod button. Change the mod to AC mode. Mod button press twice. Okay. Then if the mod is number 1, then press number 1. Then you need to enter this data. How we enter it? Press number 4, m plus 1. Number 5, m plus 1. Here, complete. There are 5 observations. T equals 5. Okay. After that point, okay. Then press shift key and number 2. Then where is the standard deviation? Half the standard deviation represented by number 3. Then equals 9. What is the standard deviation? 2.236. Number 3. You take the word okay after that. The calculation part. Finally, the aim was okay. Finally, they said, my son. Then try question number 1. Only do the Roman number 1, okay? Not try to Roman number 2. You will try the Roman number 1. Question number 1, Roman number 1. Here there are 2 outlets. You need to calculate the mean and the standard deviation of each outlet. You can use the calculator and find. Okay, hurry up. Then here, first enter the data outlet A. Then you find the mean and the standard deviation both together, okay? First you enter the data. Then you shift key and number 2, you press number 1, you can get the mean value. Okay? Again, shift key and number 2, then you press number 3 and equal sign, you can get the standard deviation. See, and then enter the data and find the mean value. First take the outlet A, then enter the data. Finish. Enter the data. You enter. Then shift key number 2, then number 1 increase. I got me standard Then, okay, you got the mean value. I think 200. 200 is the mean value. Then again press shift key and number 2. Then which number represents the standard deviation? Number 3, again 3 in %. Then you can get the standard deviation. Okay? Here 200, 232. But it's standard deviation 49. Here 41.5. These are the answers. Okay. Population exactly. Normally we cannot say. Okay. Okay. The next one is then question asks which outlet has the greater variation in the monthly sales. Normally, if we have more than one data set, we need to do the comparison. Okay, then we can do the comparison and we can identify which group has the more variation, which group has the more consistency. How we find it? Using the CV value. Okay, then here coefficient of variation. We can use to do the comparison between two or more groups. Okay, then here CV value you can use to find out the variation, but here we use two types of measurements. Okay, then what are the two types of measurements? We study central tendency and the measures of dispersion. Okay, then here we take measure of dispersion divided by measure of central tendency. Okay, which means out of the measures of dispersion we use standard deviation. Out of the measures of central tendency we use x1 into 100. This we call as what? CV value. Coefficient of the variation. Using the CV value we can easily do the comparison. Okay. We normally use the variance standard deviation, we can identify the variation, but the accuracy is high in the CV value. The reason is here we use two types of measures. Measures of dispersion and the measures of central tendency. Okay. Then hurry up, calculate the outlet A and outlet B CV values. Hurry. And you have data, then calculate. Standard deviation divided by central tendency measure, x bar. Then 40.345 divided by 200 into 100. Okay. Then second one 41.513 divided by 232 into 17.89%. Okay. Then here, all of you got the answer. And then how we interpret this? Calculation is okay. No? Interpretation. CV value high. It means variability high always. CV value is high. Variability. It can tell high. Okay. Then CV less. Variability. Okay. Then CV coefficient of variation high. It means variability high. Consistency. Consistency less. Then here consistency. Coefficient of variation and the variability. Positive relationship there. Okay. Then CV value high. Then variability high. Consistency is less. It's clear. Okay. Then tell me, question asks, which outlet has the greater variation? Which outlet? Variation is high in outlet A or outlet B? Outlet A. Outlet A has the greater variation. Which outlet has the more consistent sale? Outlet B. By CV value less. More consistent sale means during this 10 month period, their sales values are average value is there. Understood? Consistent is high in that one. Okay? No huge deviation. It's clear? Variation is hard. Consistency is very big. Variation is less. එතකොට යාළුවගේ sales එක මොකද වෙලා තියෙන්නේ? During this 10 months, average value is there. Deviation is less. It's clear? When have a master එක වගේ sales එකක් තිබිලා තියෙනවා. That is the meaning. But outlet A, comparing to the outlet B, then outlet A has the greater variation. Understood? Then normally when we need to find out the variability or variation, we require at least 2 data sets. Using the one data set, we cannot identify the variation and the variability. Clear? මේ variation එක variability කියන එක අපිට එක data set එකක් දිහා බලලා කියන්න පුළුවන්ද? At least we need 2 data sets to identify the variability. Okay, then we need to do the comparison and we can say there is a higher variation or higher consistency there. Understood? At least we need two data. Now clear? Okay, then this is the methods of dispersion. Now you can take a break. After the break, we will do the rest of the question. Okay. Okay. Then try question number 2. Hurry. Then first one asks mean and the median. Before find the median value, you arrange the data set in the ascending order. First arrange the ascending order, then find the term. Which term is the median value, then get the answer. What is the mean value of office 1? 2.168. And have you got the answer? Mean value of office 1, 2.168. Office 2 mean value 1.735. Okay. You finished median value? Median? You found? Then Office 1 median value 1.925. Okay. Office 2 median value 1.84. All of you got these answers? Then try second one. You finish. Roman number 2. Median value. Which office put up? Both. Office 1 median value, median 1.925. Okay. Did you arrange the data set in the ascending order first? Then we need to find out the 5.5th term. Then here fifth term is 1.75. Okay. Sixth term is 2.1. Okay. Then you can add them together. Then divided by 2. 2.1. Okay. 1.925. Answer. Okay. Office 2 median value 1.84. Okay. Then finish Roman number 2. Did you calculate standard deviation and find out the highest variability? Yes or no? Yes. Then standard deviation Office 1 1.37904. All of you got the answer? Office 2 standard deviation 1.138813. Okay. Then the next one asks calculate the CV value. Okay. Then CV value of the Office 1 63.6089%. Office 2 65.6376. Then which office is in the high variability? Office 2, no? Office 1 63 point something, no? Office 2 65 point something. Then CV value is high, it means variability high. Then answer is office 2. Variability of the time is high in office 2. Okay? Then Roman number 3, which measurement you can calculate? The third one, which measurement you can calculate? Yeah, then which quartile you need to find out? Third quartile. Then here, less than to one time that 75% of the problems in each office has been cleared. Less than to one time 75% of the problems. Okay, then here you need to find out the third quartile, Q3. Right? Less than below. Below to the Q3, that's 75% of the data. And here answer is Q3. Then try to find the third quartile in here. And there are 10 observations from 10 plus 1 divided by 4 into 3. Third term, sorry. Office 1, it means 8.2 fifth term you need to find out. 8.2 fifth term, no? Then both office, there are 10 observation values. Okay, here you need to find out 8.2 fifth term in each office. Okay, then how do you find out 8.2 fifth? Take the 8th term. Both office 8.2 fifth term, no? We take 8th term plus 9th term minus 8th term into 0.25. Okay. Then office 1, what is the 8th and 9th term? 3.48. Here 3.97 minus 3.84 into 0.25. And what is the answer for the office 1? 3.6025. Okay, then it means 75% of the problems in office 1 has been cleared less than 3.6025 minutes. That is the meaning in here. Understood? Okay, then here means 75% of the problems in office 1 has been cleared less than to this value. This Q3, it's clear. Then office 2, what is the Q3? 2.75. Okay, then it means less than to the 2.75. Okay, then 75% of the problem has been cleared in office. Okay, now clear? And finish section number 1 in your final exam paper. Up to that lesson, it's section number 1. The next lesson is probability. Question number 2. Then third one is from the normal distribution. Fourth one probability, coordination, fifth one probability, sixth one from the you can write it in 5 questions. In some part, the probability basic concept and the total probability based here. If you can use the grid diagram to take the answer. The raw data set calculation, or sometimes I will give the data, you need to interpret the result. Kind of question, you can get the question number. Now you have 20 marks.